Now, let's continue with the isoquants. And well, isoquants have exactly the same characteristics as iso. I mean, the indifference curves. Well, when you go to the right or above them, you get a higher quantity, and that's because the more capital and labor you use, it is assumed that the more you produce, basically. So the idea that after a certain point, adding more workers might not add to the production level is left in this abstract model. Although, I mean, the quantity, the next labor is, I think, might be very close to zero. That's possible. Or new capital, marginal product of the new capital might also be very close to zero. And when you have a lot of capital, adding a little bit worker will increase your productivity a lot. Um, and basically, I mean, adding and in order to increase and adding in order to increase the production, compensate, for example, 1 unit of labor, you need to add up a lot of capital because productivity of capital is low since you have a lot of capital. Productivity of labor is high since you have not that much labor. The opposite is also true. When you have a lot of labor, in that case, and little capital, in that case, 1 unit of labor can be replaced with a very little amount of capital the because you have already a lot of workers, so productivity of labor is low and productivity of capital is high. And since the slope of the isoquant, which is a negative slope, of course, but the steepness of it is marginal productivity of labor, capital divided by marginal productivity of labor. Labor is at the x-axis usually. That means the isoquant will get flatter as you have as you increase labor quantity. Of course, nothing will change if you had capital in the x-axis. Again, it would get more flatter as you increase the capital in this case. Remembering on an isoquant, the quantity was constant, so basically slope means actually how much slope is basically equal to the amount of minus amount of capital you need to add to replace 1 unit of labor. That gives you the slope when you have labor in the x-axis. So these are the isoquants. On A and B, basically the quantity that is produced is the same. And budget line basically shows you, I mean, this is the wage, this is the R. Well, synonymous with the capital, the profit, although, I mean, the company is making profit and it's buying capital. So, strict sense, I mean, capitals make profit, but company also makes profit. You can also think as a rent cost also. So 510 means basically you have $10,000, for example. If that's the case, so we have at first the budget, wage, and let's say price of capital, which is R. The maximum amount of capital you can buy is B over R, 1,000 over 500, which is in this case, I don't calculate it with Excel, I think that's not necessary, it is 20. Maximum amount of labor you can buy is, if wage is 10, 1,000 divided by 10, which is equal to 1,000. And the slope of your budget line is slope is, again, you have labor in the x-axis, which means the slope is, it shows the different combinations of capital and labor you can have. So slope gives you, if you reduce the quantity of labor by 1 unit, how much more capital you can get. which is, well, wage divided by R, which is actually, in this case, 1 over 50. Or, of course, it is negative, minus 0.02, because when you increase one, you need to decrease the other. I'm looking on capital labor. So slope of budget line is minus W over R. So this is the solution. This is our budget line. L0 and K0 gives you the amount of labor and capital we are able to buy if we spend our whole money for it. And K1 and L1 gives us the optimum quantities of capital and labor, which gives us the highest quantity we can produce. Of course, the price is fixed. Since the price is fixed, then and we are able to sell everything we produce, we want to increase the quantity we produce to the highest possible level. What happens if wage increases? If wage increases, in that case, well, there are two effects. Well, this line will go this way. It will become steeper because we will be higher. For example, if wage is 20, in that case now you have 20 over 500, which will be minus 25, 1 over 25 basically, or I think it will be 0.025 basically. So 20 over 500, you can calculate it. But this number will be higher without minus, and with minus, of course, it will be smaller number because we have a negative slope. So you will have two effects, just like in case of indifference curve. One is the substitution effect, which is created because now you have wage higher. Basically, the company will substitute from labor to capital. It will substitute to the product that is cheaper, basically. You also have scale effect. Scale effect is because now you have higher wage. At the same point, basically, our company is not affording to buy the amount of labor and capital it could buy before. So our company needs basically to decrease its scale because of the increase in wages, and basically its average buying power has decreased as if its budget is same. And that scale effect means, of course, also the company will decrease both capital and labor it is going to buy. Of course, substitute effect will decrease the amount of labor, increase the amount of capital you buy. Scale effect decrease the amount of labor you buy, also decrease the amount of capital you buy. So decrease in wage level will basically means that both decrease in wage level means certainly decrease in the amount of labor both, but it might mean increase in capital or decrease in capital, that is both. The reverse is true for capital. If the price of capital falls down, of course this is not that much, this is not discussed in your book, but you can basically just look to it for fun. If the price of capital basically falls down, because of the substitution effect, this will increase the amount of capital that is bought and decrease the amount of labor that is bought. But because of the scale effect, it will increase the amount of labor that is being bought and also increase the amount of capital being bought. So capital amount that is bought will certainly increase, but whether the amount of labor that's being bought will increase or not is ambiguous. And you can see here. So this is the old curve K0 L0. No, this is the old curve. I'm sorry. Well, this is the case when the wage falls or increase. Well, the initial budget line was K0 L0, When wage falls, the budget line becomes K0, L0 double dot. So initially amount of labor that is demanded is L1. The final amount of labor that is demanded is L3. And of course, when the wage falls, the amount of capital that can be bought remains constant, but the amount of labor that can be bought has increased. In order to separate substitution effect from the scale effect, we create a hypothetical budget line, which is K0 dot L0 dot, which has same slope as the new budget line, which is you can see here, which makes it parallel to the new budget line. But the maximum amount of quantity that could be reached is same as the old budget line, Q0. So it shows you just the effect of the increase in production, increase in relative price of labor, decrease in relative price of labor compared with capital. And this will lead amount of labor bought to increase from L1 to L2. So L2 minus L1 is the substitution effect. And then shift of the budget line from K0 dot L0 dot to the K0 L0 double dot gives you the scale effect. Here the relative prices are constant, but the scale has increased. So it shows you how much the increase in scale will increase the labor demanded, and that is L3 over L3 minus L2, which is the scale effect. So L3 minus L1 is the total effect in this case. So it should be wage decrease, not increase. I will change this. So what is it? What about short run and the long run? Well, both are negatively correlated with wage. If you remember, when you have in the short run a wage increase, this will basically, because of the diminishing marginal productivity, this will basically decrease the quantity at which marginal product of labor, value of marginal product of labor is equal to the wage level. So in the short run, increase in wage will end up with decrease in the number of workers that is higher, or amount of labor that is bought. But in the long run, actually, there will be even a further decrease in the amount of labor being bought, because now also in the short run, the company is not able to switch from the labor to capital. The amount of capital it has is fixed. In the long run, because it is able to alter the capital it uses, it can make use of the relatively cheap price of capital compared with the newly increased price of wage, and basically buy more capital instead of labor, which will lead a further decrease in the demand for labor. So, meaning of the model: when wage level decreases, employers will substitute labor for capital because they will become relatively cheaper. When wage level decreases, employer also increase the production level, since decrease in wages allow them to save part of their budget when they maintain old production level, and they can use this extra budget to increase production level. Well, of course, this analysis still needs to be tested and basically not necessarily completely true. But note, I just want to show you how the model can be applied to make some historical analysis. In 18th and 19th centuries, throughout that period, arguably because of the increase in production level and decrease in cost, the cost of capital has fallen. And when cost of capital falls, this will lead through substitution effect companies to substitute capital for labor, but it will also arguably lead companies to increase their scale of production and hire more workers.